Yes, okay. So today we are starting our chapter all about radicals. Yeah, so first we're going to recap. I know you already know some stuff about radicals. We can simplify radicals. So let's start by reviewing what we already know real quick. All right, let me get a nice pen here. Let's try this side. Okay. Oh, brown. Let me shut this thing off. This helps. You can see your papers okay? So I know this is now unit 5, but this was chapter 7 in the book and everything is already titled chapter 7, so I'm going to just stick with it. So this is going to be 7-1. Square roots. And higher index roots. What? What even is that? Don't worry, I'll tell you. All right, so let's recap what we already know. If I wanted you to simplify the square root of, let's say, 50. 50 is not a perfect square, right? No. However, if I look, I gave you this handy dandy list right here. So you have a list of your perfect squares right here. 1, 4, 9, 16, 25, blah, 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 blah. Do I have a number in this list that divides evenly into 50? 25, right. So do you remember we would split this up into the square root of 25 times the square root of 2? So this just comes out as 5/2. Right? Old news? You remember this? So let me give you one to try. Do square root of 300 for me real quick. Simplify that one. So what's the perfect square that divides into 300? One, yeah, you always want the largest perfect square. There's more than one, right? 4 goes into 300, 25 goes in. I always want the largest perfect square that goes in. So in this case, it's 100. So that would split into 100 times 3. And the square root of 100 is just 10. So that simplifies to be 10√3. Okay, is everybody with me? And you remember this? And this is old news? Perfect. So let's step it up a notch. What happens when I ask you to take the square root of a variable? Let's start off real easy. What would the square root of x squared be? Just x, right? Because x times x is x squared. So that is just x. So what's the square root of x to the 6th, let's say? It's x cubed, right? It gets weird when you're thinking about exponents because you're like, well, 6 isn't a perfect square. So like, what am I supposed to do here? Guess what? It doesn't matter. If it's an even exponent, it is a perfect square, as long as it's an exponent. Why? Because if you think about it, x to the 3rd times x to the 3rd really is x to the 6th, isn't it? So when you're dealing with exponents, all I really have to do is just cut it in half. And that is the perfect square. So let's try another one. If I ask you for the square root of x to the 22nd, you're like, oh, that's easy. It's just x to the 11th. That's it. Does that make sense? You with me? Yeah, okay. Okay. So let's combine these. Let's maybe try a number and a variable. What if I did something like the square root of, let's do 32x to the 10th. Take the square root of that. Simplify that as best you can. Okay, so I'm dealing with a number and variable. So you could kind of break this up into two separate problems because the number and the variable really have nothing to do with each other. So what I might do is I might actually separate out. I'm going to handle the square root of 32 and I'm going to handle the square root of x to the 10th. I'm going to handle both of these things. Let's just focus on the square root of 32. What's the biggest perfect square that goes into 32? 16. So that would just be 16 square root of 2. So for that chunk, I get 4 times the square root of 2. Everybody okay so far? For that chunk? What would the square root of x to the 10th be? X to the 5th, right? So that just becomes x to the 5th. Remember that this is all multiplication. So if I want to write this answer all nice and neat, I'm going to multiply anything that's not in a square root together, and that goes first. And then anything that would be left in the square root is going to get multiplied together and stay at the end. So this answer just looks like this in the end, 4x to the 5th. And then I stick that root 2 on the end like that. How's that so far? We're okay? All right. You ready to up the ante a little bit? Okay. What happens when I want you to take the square root of something like x to the, let's go 7th. Well, now what? That's not a perfect square anymore. I can't just cut it in half. Ethan? Exactly. Just like when it was a number, I want the largest perfect square that goes into this. So for a square root though, since it's all just multiplication, I can actually split this up. Watch this. Square root of x to the 6th times the square root of x to the 1st. If I multiply those two things back together, don't I get right back to x to the 7th? Right? Just like any of my other things. If I multiply 16 and 2 together, I get right back to 32. So all you really have to do for a square root, you just go down by 1. I just split it up into, because there's always an even number right before an odd. So if I just break it up like this, now this is a perfect square. So this piece, what's the square root of x to the 6th? It's just x to the 3rd, and then I just leave square root of x on the back. That's as simplified as I can get. Okay, let's mix them together now. Let's try numbers and variables. And well, actually, hold on. Let me give you one more to try. That's just a variable. How about x to the, I don't know, 21st. Simplify just that one for me. Okay, you got it? So what am I going to split this into? X to the what and x to the what? Yes, you just go down by 1 because that's an even number. And x to the 1st. So what's the square root of x to the 20th? X to the 10th, and then I just leave the square root of x on the end. Did you get it? All right. Okay, now let's mix them together. So let's try the square root of about 40x to the 8th, y to the 3rd. Ooh, try that one.
2x to the 4th, like root 10, like y to the 3rd.
I think
Something like that.
you're so close. You have 2 of the 3 parts right. You just gotta handle the y. Can't y to the 3rd be simplified? It can. Let's go piece by piece. So let's separate them. I have the square root of 40, the square root of x to the 8th, and I'll deal with the square root of y to the 3rd. So I'm really gonna handle each of these pieces individually. Zoom in a bit. All right, so 40, I want the largest perfect square that goes into that, which is just 4. So that one will split into square root of 4 times the square root of 10. So that means I just get 2 times square root of 10 for that chunk, right? Now, what's the square root of x to the 8th? X to the 4th. So that one I don't need to, that one just, I know the answer is just x to the 4th. But now y to the 3rd, right? That's not a perfect square. So I got to do this trick where I go one lower. I can split this up into y squared times y to the 1st, right? Because isn't that really y to the 3rd if I multiply them together? Yep.
Can I like come see if my answer was right before I see it up this so I can try to redo it? So I'm trying to.
I don't know what the answer is.
Oh, all right.
So, yeah, sorry. Just cover it up. Yeah, I don't know it until I do it. I just make these things up. I appreciate you wanting to check, but yeah, I don't know what the answer is yet. But I will in a minute once we do it. What is the square root of y squared? Just y, right? So that's just going to come down as a y. You can't simplify the square root of just y any further. I can't like go one lower because I just said y to the 0. I'm not going to get anywhere. So that is as far as that one can go. So now that I'm here, I want to multiply everything that's not in a root together. Everything that's not in a root. All of that's going to get multiplied together and that goes in front. Everything that is in a root will get multiplied together, go in one root together at the end. So if I multiply everything not in a root, 2x to the 4th y. And then everything that is in a root will get multiplied together. 10 times y is just 10y. So that would be my answer. Is that what you had?
I did 4x to the 4th y squared radical 10.
I think you have to take the square root of that, right? So that 4 will turn into a 2, and the square root of y squared will just be y. All right, let me give you one more like this to try before I'm just going to keep turning up the difficulty levels here. So let's try one more that's kind of similar to this. What if, let's say I put a number out in front, like how about -3 times the square root of 150 is popping into my brain. So let's do 150 y to the, oh, I know. Let's do y to the 9th and then z. Ooh, see how you'll handle this one. Yep. Ah! I have no idea what it is. So even if you told me, I mean, you can tell me, I'll write it down. We'll see if you're right later.
Negative 15 y to the 4th fractional 5 second. No, 5 y second.
I think that might be right. Just for me doing, I don't know how you did it so quickly, but I think you're right.
No, 6 y second.
Oh, yeah. Oh, I definitely can't do it that fast. I gotta go piece by piece. Okay, got an answer? Okay, so piece by piece. Don't get thrown off by this -3 on front. It's just multiplication. So I'm just going to do -3 times whatever the square root of 150 is, times whatever the square root of y to the 9th is, times whatever the square root of z is. That's all. It's all just multiplication. I'm just going to break them apart. There's nothing really for me to do with this -3 right now. So I'll just bring it down. 150, that breaks up. Biggest thing that goes into 150 is 25. So that's now 5, and that's a root 6. Okay, square root of y to the 9th. You got to split that into y to the 8th. You always go down by 1. What is the square root of y to the 8th? Y to the 4th. And then square root of y to the 1st. I can't do anything with that, so it's just going to stay square root of y. Similarly, I can't do anything with square root of just z. I can't go one lower because I'm at 0. I can't split this up. So that's just going to come straight down to square root of z. I can't simplify that any further. So now I'm here. Is everybody okay how I got here and all these pieces? Because now my final answer is not so bad. I'm just going to multiply everything not in the house together. So I get -15 y to the 4th. That's it. So that's my front number, -15 y to the 4th. And then everything that is in a root will get multiplied together, go all together at the end. 6yz. And I'm done. Sort of. There is one more thing that I got to tell you about that kind of adds a layer of complexity, but unfortunately it is a necessary evil. Like what?
Isn't square root of 9 just 8? So why would it be?
Because as an exponent, it doesn't work that way. Because y to the 3rd times y to the 3rd is only y to the 6th, right? It's not y to the 9th. Yeah. So exponents, you always got to cut them in half. You're always cutting your exponents in half. So that's why I got to split it up.
You split it up to the next even number.
Right. So you always go down by 1 because you have an even number right before every odd.
Yeah.
And then I can split that one in half. That's how it went from 8 to a 4. But again, once I get a y to the 1st, I can't go any lower than that. So I just leave it. Then I just take half. So,
And you get rid of the square root.
all righty. So I have this very important rule that we now need to talk about, which is weird, but once you get the hang of it, it's not so bad. All right, first, before I do that, I just want to remind you of the parts of a radical, which you may not even be aware of. So when you have a square root or I shouldn't say square root because there's actually a number that goes right here. There's a little tiny number that goes right there. When it's a square root, that number is a 2, and we just never write it. Just like when I'm writing x to the 1st, I don't usually write that exponent of 1. That is called the index. So that little tiny number that sits on that little, I call it a bird on a perch. So that's like a little birdie, and here's the little perch. So your little bird on a perch is called the index, and that tells you what root you're taking. Is it a square root? Is it a cube root? Is it a 4th root? I don't know. That number would tell us. So if there is no number, we just assume that it's a 2. All right, so when I say index, now you know that's the thing that we're talking about. All right, so you ready for this wild rule? If your index is even, so if it's a square root, a 4th root, a 6th root, an 8th root, whatever it is, if that's an even number, and you take that root of something in here that has an even exponent, and the answer that comes out is odd, You're supposed to use absolute values around that number. What? What are you even talking about? I'll try and show you. Okay, so let me first write the rule down and then we'll look at some examples. So big star, if you take, let me get another color. There's a little saying that we have to help us remember this. Even, of course this doesn't work. Even index from an even exponent and your answer is an odd exponent, you must use absolute value bars. Okay, thank you. So our saying is even, even, odd. Even, even, odd. Even index, even exponent, and then your answer has an odd exponent. We're going to put absolute value bars around it, and I'll explain to you why in just a second. All right, so let me give you an example. Let's say I want to take the square root of x to the, let's just do x squared to make our lives easy. So remember that the index right here is a little tiny 2 that we never write if it's a square root. So that's even. This is even. And then what's the answer that comes out of this? What is the square root of x squared? X to the first. That is an odd exponent. So what I'm supposed to do is I'm supposed to actually not leave my answer like this, but put my answer in absolute value bars. So even, even, odd gets absolute value bars around it. Why? Why would you even bother? Why do you care? So let me try and show you with an example. Let's see if I can scoot over here and just show you. If I ask you what the square root of 9 is, and it's written like this on the paper, right? So remember we talked about this a couple chapters ago. If it's written like this, that indicates that you want the principal square root, so only the positive one. If I want both roots of 9, I'd put a plus and minus in front of it. When you take a square root, you need to consider both roots. But if I'm doing a worksheet and it just says square root of 9, I'm just going to write down a 3. If they want both roots, they're going to write plus minus in front of it. So the square root of 9, as written right there, is just a 3. Okay, now watch this. If I try to take, let's take negative 3. If I square negative 3, yes, I do get right back to 9. So shouldn't I be able to take the square root of 9 and it come out as a negative 3? Well, that's not what this notation means. This notation says, hey, the square root of this as written should just be positive 3, but you're saying it's a negative 3. Even, and then that, I'm doing x squared in there, right? So I have an even, and they come out as an odd. So if I put the absolute value bars around it, Now it's a true statement because the absolute value of -3 is +3 and I haven't violated anything. So it's a little annoying rule to get used to, but once you get it, it's not so bad. Even, even, odd. So let's go back and look at some of our answers and see if we need to add any absolute value bars to them. So let's go to the last one we did before I start talking about this. This one right here. So you go back to the original. It's an even index. These are both odd though. If it's odd, I don't need it. So if it's, I'm looking for that pattern, even, even, odd. I don't have it. I have even, but these are both odd. So I don't need any absolute value bars in that answer. None at all. Let's go to the one before it. It's 40, blah, blah, blah. Okay, even, even, but then when I look at my answer for it, it came out as even. I still don't need absolute value bars for that because I was even, even, even. Doesn't matter. Even, odd, I already broke the pattern, so I don't need them for this one either. Let's check this one. Even, odd, already broke the pattern. Even, odd, broke the pattern. But look at this one. Look at this one. Even index, even exponent, and look at my answer. It came out as odd. So this answer right here should actually have absolute value bars, and it's just around that variable. So I just need absolute value bars around that x equal. Annoying, I know, but so let me jump right back here because I think I have one more. Actually, both of these, right? Even, even, that came out as odd, so I should have absolute value bars around that one. Even, even, came out as odd, so I want absolute value bars there. This only applies to variables. It does not apply to numbers. It's just variables. How are we feeling so far? Goodish? Okay, all right, all right, all right. I have one more thing I gotta show you and then that's it for today. You ready? Okay, okay. So let's leave square roots behind for a moment. How do cube roots, fourth roots, fifth roots work? Well, basically the same way. You're just dealing with cubes instead. So let's try or whatever root you're at. So let's try a cube root one. Let's do the cube root of, how about 24? Actually, let's just do a number first. Let's just simplify just this, just as a number. So I am not looking for the largest perfect square that goes into this because I don't care about perfect squares. I care about perfect cubes. Look at that list I gave you. Look at your list of perfect cubes. See them? See them? So if it's a cube root, I want the perfect cubes. 1, 8, 27, 64, yada, yada, yada. What's my biggest perfect cube that divides into 24? 8, obviously. So this is going to split into the cube root of 8 times the cube root of 4. I mean 3. See? Just kidding around. There we go, because it's 8 times 3, that's 24. All right, so what's the cube root of 8? 2. So this thing simplifies into 2 times the cube root of 3. Huh? Huh? Yeah? Let's try one more. That's just numbers before I make things crazier. How about the simplify for me the cube root of 250. So look on that list, that handy dandy little list I gave you. You know what I might recommend you do? I might recommend you take a picture of this list so that you have it handy whenever you need it, just in case you don't have this paper with you. Because it's got all your things right in one convenient little spot. So what's the largest perfect cube that goes into 250? 125. So this thing splits into the cube root of 125 times the cube root of 2. Also, can I make this, I'm gonna urge you. We're all lazy. I'm with you. I don't like writing these little threes all the time. You have to. If you don't write it, a square root and a cube root are completely different from each other. I know you think in your head, oh, I know it's a cube root. I'm just not gonna write the 3. I'm telling you, you're gonna get messed up. So whatever the index is, if it's not a 2, you have to write these numbers right here. I know, I want to be lazy too, but you can't be so lazy that you get the whole problem wrong. Right? All right. What is the cube root of 125? Just a 5. And then that just stays cube root of 2. Yeah? Yeah, 5 times 5 times 5.
Oh, yeah.
And it says it right on your little list, right? 125, there it is. The cube root is just a 5. All right. All right. Let's sprinkle in a variable. We'll start off easy. What's the cube root of x to the 3rd? Just x, right? Because x times x times x gets me x to the 3rd. All right. Then what's the cube root of x to the 6th? X squared. Because isn't it just x squared times x squared times, because x squared times x squared times x squared really gets me x to the 6th. Oh, cool. So, all right, what about the square root or the cube root of something like x to the, I'm gonna jump ahead here. How about like 21st? What do you think that is? It is, it's just x to the 7th. Are you noticing a little pattern here? What are you doing to get this number so quickly? Exactly, you just take the exponent divided by your index. That's your root. And that works for any of them. 4th roots, 5th roots. So the root of any variable is just the exponent divided by the index. That's it. Oh my gosh. So that's kind of a big deal. So you could do any of them now. So watch this. What if I ask you a 4th root of x to the 20th? What's that? X to the 5th. See how easy? Oh my gosh. So what's the 6th root of x to the 42nd? Oh my gosh. That's it? Yeah, that's it. And then we do still have to apply that even, odd rule. Even, oh, it came out odd. So this one should actually have absolute value bars around it. Even, odd. Oh, bars around that one too. Let's do one more. What if I did like, what if I asked you for the 5th root of x to the 30th? That's it. It's just x to the 6th. I don't need bars here because I didn't have an even root to begin with. Okay, are we feeling all right-ish? So what happens when I ask you to do something like the cube root of x to the, let's say, 14th? Because now you hit a snag. I can't do 14 divided by 3. I mean, not in a whole number anyway. Huh. Well, remember what we were doing when it was a square root and the number was odd? I just went down by 1, right? I split it up. So if I go down by 1, I get 13. 13 is not divisible by 3 either. But, Ethan, go down by 2. Go down by 2. Split this up. Oh, I feel a sneeze coming. Cube root of x to the 12th times the cube root of x to the 2nd, right? Wouldn't x to the 12th times x to the 2nd really be x to the 14th? Yeah, but now I can do this because that's just 12 divided by 3. That just becomes x to the 4th. This chunk right here just can't be simplified. It just stays. That's my simplified answer. Phew, I knew it was coming. I don't have to worry about absolute value bars because it was odd to begin with. All right, you try this one. How about the 5th root of x to the, I don't know, let's do 16th. So always start at 16. Oh, I can't do 16 divided by 5. Okay, keep going down until you hit a number that you can divide by 5. This time, how far do you have to go down? Just 1, right? If I just go down 1, now I get to 15, and 15 is divisible by 5. Oh, all right. So I'm going to split this up. That'll be the 5th root of x to the 15th times the 5th root of x to the 1st. And the 5th root of x to the 15th is just x to the 3rd. And then you just leave this one here. That's it. That's my answer. I'm done. So the only way that these get more difficult is when we're combining numbers and variables together in the same problem. So let's try one. Let's do a cube root of something like, let's do 16 y to the 9th, z to the 23rd. Let's do that. So everybody give that one a shot. Just go piece by piece, just like we did before. Break them up into 3. It's really like 3 mini problems in one. So I would handle the cube root of 16 by itself, the cube root of y to the 9th by itself, and then the cube root of z to the 23rd by itself. Okay, so while you're doing that, I'm going to hand out your assignment. So give it the old hole punch. I miss the days of having a copy machine. So much for me. So nice. I didn't know what luxury I had.
I didn't think it.
Oh. You're welcome. Okay, so let's see how we did. 16 is not a perfect cube, but if you look at your list, you very quickly find out that who is the biggest perfect cube that goes into 16?
What are you looking at? No, the problem we just did. Oh, I was like, what?
Yep. 8. So this should split into the cube root of 8 times the cube root of 2, right? Because 8 times 2 is 16. I know what the cube root of 8 is. Let me zoom in on this problem a little bit. I know what the cube root of 8 is. What is it? Just a 2. This does not simplify, so that just stays cube root of 2. All right, cool. Now let's move on to this mini problem. What's the cube root of y to the 9th? Y to the 3rd. You always, with the variables, you're just doing exponent divided by the index. If it comes out nice, great, you're done. That's just y to the 3rd because 9 divided by 3 is 3. Now I run into a little bit of a snag here because 23 divided by 3 is not nice. So I have to split it up. So go down by 1, 22. 22 is still not divisible by 3. Okay, I'll go down by 2, 21. So this, I hope you split into the cube root of z to the 21st times the cube root of z to the 2nd. Because z to the 21st times z to the 2nd really is z to the 23rd. But this, what is the cube root of z to the 21st? Z to the 7th. Now, this chunk right here just doesn't simplify. It just stays cube root of z squared. How do I know it doesn't simplify? If my exponent is smaller than my index, you're done. You can't go any further than that. So to write my final answer, I'm just gonna multiply everything that's not in a root together. 2, y to the third, z to the 7. Then everything that is in a root, it's multiplied together in one root at the end, 2z squared. Yes. Oh, and then check for absolute values. Do I need them here? No, you go right back to the original. Once I see that's odd, it's already broke the pattern. I'm only looking for even, odd. So if I'm starting off with an odd bird on the perch right there, I'm already done. I don't need it. That's my final answer. Okay, so we're gonna practice some of these. Why don't we do, oh, I'm thinking multiples of 3 on both sides. Multiples of 3, both sides, so 3, 6, 9. Oh, you guys are too young. You're supposed to respond back to me with the next line.
What?
Do you not know?
No.
Well, anyway,
Don't explain it.
I can't. You guys just need to learn your Lil Jon lyrics.
Wait, so all odds?
Hold on, let me stop this video before the internet knows how much I